Hi, in this video, we will talk about the derivative as a way of change. And now let us start with velocity, speed, and acceleration then. Instead of here, suppose an object move along a line with position s equal to f of t. Okay, then we know that the velocity basically is the derivative of f, which is the derivative of the position function, right? And then we also learn that the speed is actually the absolute value of the velocity. Okay, again, velocity is a vector, so you have a directions. So positive velocity meaning is the particle is moving forward, negative is moving backward. Okay, but the speed is actually there's no direction with the speed. Okay, so therefore we take the absolute value of the velocity will be the speed then. And accelerations is actually we define that as the way of change of velocity is the accelerations. So therefore, in this case, how do we find accelerations? Basically, we take the derivative of velocity, we will get the accelerations then, okay? Which is the second derivative of the position functions. So therefore, you will see that when we try to find a of t, we take the second derivative of f. Okay. Okay. Then now let us look at our first example now. Okay. Now here is a suppose the position of an object moving horizontally after t second, giving the function s is equal to f of t, where s is measured in feet. With s greater than 0, then we correspond to positions right of the origins. Okay. Okay. So now I have a position functions. And then t is between 0 and 4. Okay. So we have a time, right? Okay. So right now, what I would like to do is I would like to determine the accelerations of the object when its velocity is 0. Okay. So to this problem, how I first approach the problem may be based on this statement right here. First, I would like to know when the velocity is 0. Okay, so I would like to start with this. So first, I would like to find velocity. Okay, I mean, in this case, we know that v of t is equal to f prime of t. Okay, so then I will have -6 times 3t squared plus 36 times 2t minus 54, right? And which is -18t squared plus 72t minus 54. Okay. Then second, I would like to set v of t equal to 0. Okay. Then now you will see that to this one, what we can do is maybe we can just take out -18 t squared minus 4t plus 3 equal to 0. Okay. And we can factor. So I will have t minus 1, t minus 3. Okay. So -1 times -3 give me +3. -1 plus -3 is -4. Okay. So then in this case, we find that t is equal to 1 and also t is equal to 3 then. Okay. And now we need to find the accelerations. Okay, so I will have a of t. Basically, it will be v prime of t. Okay, so in this case, we have negative 18 times 2t plus 72. Okay. Then I have a of 1 is equal to negative 36 times 1 plus 72. So I have 36. Okay. And maybe let us try to see what is the unit in this case right here. Okay. So in this case right here, we know that to the velocity, then is the way of change, okay, between the position functions over time. Then now the accelerations is the rate of change of the velocity over time. So therefore, in this case, probably the acceleration will be feet per second squared. Okay. And of course, a of 3, it will be negative 36 times 3 plus 72. Then in this case right here, then I have negative 108 plus 72, so I have negative 36 then. Also feet per second square. Okay. Okay, so this is how we actually work with problem number 1. Okay, and then problem number 2 is actually we work with again position functions that suppose a stone is fall vertically upward from the edge of the crib. Okay, with its initial velocity of 64 feet per second. Okay, from the height of 32 feet above the ground. Okay, okay, so now we have a situations. Okay, suppose well, a person is standing from the edge of a crib, and then this one right here is 32 feet above the ground. Okay, and then right now you would like again the person is actually fold the stone upward. Okay, and then we know that if you throw it upward, then eventually the stone will go down, okay, and hit the ground. Then. And the speed that you throw it out is actually with 64 feet per second. This will be the velocity, okay? We call this the initial velocity, meaning when t go to 0. Okay. Now, let us look back to the problem now, okay? So let's see what we need to do with this problem, okay? First, they ask you to determine the velocity of the stone at after t second. So then this is actually easy because again, v of t basically is equal to s prime of t. So I will have negative 32t plus 64. Okay. And then now it asks me that when does the stone reach its highest point? Okay, so let us look at the diagram. Okay, so meaning I would like to know, okay, what is the height of this? Okay, okay. How do we actually work it out this problem? Of course, I know that in this case, I need to work with the s functions. Okay. So that means what? If I know that the time that I reach this height right here, okay, then I will be able to plug it into the S function and then solve it. Okay. Then one other information that I know about this. Okay. Now, let us think about this at this moment right here. What is the speed or what is the velocity of the stone? Oh, in this case, basically in this case right here, the velocity must be 0 then. Okay, because the basically you have an upward motion and then go to downward motion, meaning what at this moment the stone must stop then, right? Okay, so therefore in this case right here, I would like to see, okay, that's mean at this moment the stone is actually the speed of the stone is 0, and then maybe I would like to find out that what time it when it's happened. So therefore, if I could find out that, okay, the t sub 1 in this case right here, or maybe e equal to t sub 1. So if this is the case, okay, then once I know that, oh, the time t sub 1, then what I could do is I could plug it in here to help me to find the height then, okay? Okay, so therefore to this one, oh, basically, what I need to do is, oh, I need to set, okay, the v of t equal to 0. So I'm going to set negative 32t plus 64 equal to 0, okay? And I just need to solve for t. Then of course I find out that, okay, 2 seconds later, then I read the highest position, okay? Then now, if the problem asks me that, oh, okay, what is the height? Then of course I would like to write down S of 2 is equal to negative 16 2 squared plus 64 times 2 plus 32 then. Okay, negative 64 plus 128 is 64 plus 32 is 96. Okay. Actually, I found out that in this case, the height is actually 96 feet then. Okay. Okay. And now the next problem is when did the stone strike the ground? Okay. So meaning I would like to know in this case, this time now. Okay. Okay. Then again, what information do I know about when they strike the ground? Okay. If I strike the ground, it means that my position must be 0 then. Okay. So then now, basically what I need to do is I just set the S of t equal to 0. Okay. And again, I found out that, oh, the number, the coefficient, right, is actually a multiple of 16. So maybe let us take out the negative 16. Okay. Then I found that in this case, I will not be able to factor. Then maybe let us use quadratic formula to help us to finish the problem then. Again, if you remember that at squared plus bt plus c equal to 0, then t will be negative b plus or minus square root of b squared minus 4ac. over 2a, right? Okay, then maybe let us try to do this then. T is equal to negative b plus or minus square root of b squared minus 4 times a times c all over 2a then, okay? Again, in this case, I don't care about the negative 16 because I could divide both sides by negative 16, right? It's got 0. Okay, then now. Okay, so now let us try to simplify this. Square root of 24 is a square root of 4 times square root of 6. And now we could factor the 2. Okay. And now, of course, we have two results. One is 2 minus square root of 6. Another one will be 2 plus square root of 6. Okay. And then we find that 2 minus root 6 is a negative number. Okay. Because again, square root of 6 is a number that bigger than square root of 4, right? So then this is 2 already. So meaning root 6 is more than 2. So this is negative. So we are going to reject this answer. So this will be my answer then. So then now the last problem is with what velocity that does the stone strike the ground? Okay, so right now we would like to work with the velocity. So again, we know that v of t is negative 32t plus 34. And then in this case, when t equal to 2 plus root 6 is hit the ground, so therefore I'm going to evaluate v of 2 plus root 6. So my answer will be negative 32 root 6 feet per second, okay? And you will see that the velocity is negative is okay, right? Okay. The reason is, you see, the stone is going downward, okay? So that's why the velocity must be negative then. Okay. Okay, so then now let us look at the next topic that we would like to cover, okay? So right now I would like to talk about the cost, revenue, and profit now, okay? So this type of application is related to like business or in economics then, okay? Okay, then let us try to define, okay? So when we talk about cost, we have a variable cost and the fixed cost, okay? So for example, like the fixed cost is just like the rent or the utility that you have to pay it like every month. That is the fixed cost that you have. And the variable cost is directly related to the number of the unit produced. For example, like the raw material or the labors that you have, okay? One thing about this is if you are like making a products, right? If you want to produce more, of course, you have to purchase more raw material. So that's why this become your variable cost. Okay, so now, in this case, C of X is give the cost to produce the first X item in the manufacturing process. And then now, what does this mean by the marginal cost? Okay, basically the marginal cost in calculus is considered that we are looking for the C prime of X, meaning the change in the cost over the number of items then. Okay, so that's why you have a unit is cost per items. Okay, it's the rate of change in the total cost that arise when the quantity produced changing by 1 unit. Okay, so in this case, the idea about the marginal cost is the additional 1 unit. What is the cost to make additional 1 unit? Okay, so this is kind of like the idea about the marginal cost. Okay, then in this case, how about the revenues? Revenues basically is the sale price per unit multiplied with the number of units sold. Okay, so in this case, for example, if you have a product that the sale price is maybe $100, and then you sold it out for 10 units. Okay, then of course in this case your revenues will be 1,000 then, right? Just 100 times 10, so which is 1,000. So this is exactly how we actually find the revenues. And then the marginal revenue is approximately equal to the increase in revenue from selling 1 more unit of the products then. And then now, how about the profit? Okay, now basically the profit is the revenue minus cost. It will be the profit then. Okay. Then the marginal profit is the rate of change in profit with respect to the number of the unit produced and sold. Okay, again. Then if profit is positive, then we make profit. If profit is negative, then we make a loss. Okay, now in this case right here, then maybe let us look at this diagram right here, okay, to understand what is going on here. Okay, now when I look at this diagram right here, first of all, I notice that this line right here, it must be the cost, because again, we have a fixed cost right here. No matter what you need to do, then you need to pay that amount of money, right? Okay. And then now, okay, to the simple case that basically the cost is when you make more, then of course the cost is actually increasing, right? And then this line right here is the revenue now, because again, if you didn't do anything, then your revenue must be 0. And then when you sell more products, then your revenue will increase. Okay. Then in this case, if your revenue, okay, your revenue is more than the cost, then of course in this case, meaning you make the profit. Okay. If your cost is more than your revenue, okay, then in this case you will make a loss. Okay. And of course, in this case, it means that if you have the revenue minus cost, you will get a negative number, right? Right. So that's why you lost. Okay. Then now you will notice this. There is a point that is kind of like the intersection between the cost function and the revenue function. This point right here is what we call the break-even point. Okay. So where P is actually equal to 0, that means you didn't make any profit, or where R is equal to C, that you have a break-even point. Okay. So therefore the break-even point is the intersections point of the cost function and the revenue function there. Okay. Okay, so now then let us try to work on our first, that means the next example now. Now I would like to let C of X represent the cost functions of producing X unit, X item, and this P right here is actually the sale price per item. Okay. Now again, this small P right here is not the profit. Okay, is the sale price per items if X item are sold. Okay. So then this is the sale price. This is the cost functions. Okay. Then now let us try to work on our first example now. I would like to find the marginal cost. Then of course, we know that the marginal cost basically is the C prime of X. So then I will have negative 0.08x plus 100 then. And then now I would like to determine the marginal cost when X equal to 500. So therefore, in this case, I would like to find C prime of 500. So it will be negative 0.08 times 500. Okay. And then plus 100. So then in this case right here, I will have negative 40 plus 100. So the result that I have is actually 60. Okay. Now I would like you to think about what is the unit of the C prime of 500, meaning the unit of the 60. Okay. Okay. Yeah. You're right. It should be $60 per item. Okay. Okay. Then now, what does this mean? For this C pi of 500 equals $60 per item then. Okay. So then you have to go back to think about this is how do we talk about this? Okay. Okay. So then to this one, I will say that it will cost $60 to make from 500 units to 501 unit then. Okay. That means when you want to make the 501 unit from the 500 unit, it will cost you $60 to make that 1 unit. Okay. Now you have to understand that this one, the C, that means the marginal cost will be different. Okay. For example, so if I want to find C prime of 400, okay, then it will be like negative 0.08 times 400 and then plus 100. So then this one will be negative 32 plus 100. So it's actually, it will be what, $68 per unit then. Okay. So again, in this case, you have to understand that what is this $68 per unit, right? It means that when you try to make it from 400 units to 401 units, okay, it will cost you $68 then. Okay, so this is the idea about the marginal cost. Then now, if I want to find the revenues, okay, then in this case, remember, revenue is what R of X is equal to the sale price per unit multiplied to the number of unit. So, okay, this is what it means. Okay. So then now to this problem. Okay. The sale price, okay, is this one. So then in this case, my revenue is equal to 200 minus 0.1x. And then the number of units sold will be x, right? So then it will be 200x minus 0.1x squared. Okay. Then now, if I want to find the profit and the marginal profit, then how do we do this? Now, again, the profit functions. Okay, again, remember this is the profit function, not the sale price, okay? It is actually equal to R of x minus C of x. So which is 200x minus 0.1x squared minus negative 0.04x squared plus 100x plus 800. Okay. Then it is equal to 200x minus 0.1x squared plus 0.04x squared minus 100x minus 800. Negative 0.06x squared minus 100x minus 800 then. Okay. Okay. Then now my marginal profit, it will be negative 0.12x plus minus 100 now. Okay. So this will be the marginal profit. Okay, so that's it for today then. Thank you.